Hello and welcome to our capstone project, a sensor data validation for optimization of garbage collection using machine learning. In this project, we the authors Kabeer Gulati, Zuhaib Ahmad and Abhishek Raj did a comprehensive study of different approaches to error detection and sensor data validation. The first approach we chose was variance based error detection, in which we use the variance of the input data set to determine whether the data is erroneous or not. If the variance passes a certain threshold, then we can declare that the sensor is faulty. The MATLAB code to calculate and display the variance of an arbitrary data set is shown here.
The next approach is uncertainty-based error detection, in which we calculate the uncertainty index based on the guide to expression of uncertainty in measurement of an arbitrary dataset to analyze whether the data from the sensor is faulty or not. Following is the MATLAB code for the same. The third approach is for when a sensor fusion is used. It is the calculation of a squared predicted error based upon principal component analysis. An abnormal increase in SPE indicates that the sensor is faulty and data from it might not be valid.
Fuzzy logic is a way to model logical reasoning where the truth of a statement is not binary but somewhere between absolute truth and absolute false. Fuzzy inference system is a function that maps input to output using human interpretable rules instead of abstract mathematics. There are primarily two types of fuzzy inference systems, Sugeno and Mamdani. Here we used the Mamdani fuzzy inference system. To implement fuzzy system for sensor data validation, we take three parameters in consideration: data from the sensor, which is distance, rate of change of data, and standard deviation. These are the crisp inputs for our fuzzy inference system. We then plot a membership function for each input. Here we used a Gaussian relationship function for illustration purposes. Now we form a relationship matrix that will fuzzify our inputs. The output we get from evaluating the fuzzy system will be our data confidence. The code below is the fuzzy inference system fully in command line in MATLAB. By using the eval FIS command, we can obtain the data confidence for any set of values. Now that we have a skeleton of what we want from our fuzzy system, we could use this knowledge to create a more robust system that could be implemented cross-platform. We can do this via Fuzzy Logic Designer, which is provided by MATLAB. MATLAB offers a fuzzy logic designer that makes it easy and less prone to error to design complex type 1 fuzzy system with multiple rules and crisp inputs. Here we used the fuzzy logic designer to reconstruct our fuzzy system and make it more robust and flexible. We can access all the membership functions from here and can change them accordingly to our needs. From here we can access the rule list for our fuzzy system. The rules are created in human understandable language, makes it easier to work with. Fuzzy Logic Designer also allows us not only to get the data confidence in a much easier manner, but also allows us to plot it against various inputs. From here we can change the x and y axes to generate all possible surfaces. With this, we conclude that variance and uncertainty are computationally less taxing and can hence be used in embedded device itself. Principal component analysis can be used whenever there is a sensor fusion in place, and fuzzy systems are best implemented on the cloud side of the project.